All right, let's do some simple examples with probability just so you can kind of get the idea of how to think through some of these problems. And I'm probably going to start mentioning this at the beginning of every video, is that if you're just sitting here and watching me and not doing this stuff, you're only screwing yourself. The only way you get good at math is actually by doing it. And if you just sit here and watch the videos and hope you do well on the tests or eventually figure it out, you're a loser, man. And losers don't watch my videos. So actually practice these problems. You'll realize how helpful it actually is. You'll thank me later too. All right, what's the probability that a 6-sided die lands a 3? So let's first list out all the possible outcomes that you could get from rolling a 6-sided die. And if you've played any board game, you'll know what I'm talking about here. So you can roll a 1, a 2, a 3, a 4, a 5, or a 6. And in this case, we want, what's the probability that this die lands on a 3? So this is our favorable outcome. There are 6 total outcomes, but there's only one that we care about, or one that we want. So probability that the dice lands on 3 is equal to 1, because there's only one 3 on a dice, or on a die, I should say. And there are 6 there's 6 total numbers that it could land on. So a 1 in 6 chance. And if we want to express this as a percent, this is going to come out to be 16.66 repeating percent. All right, what's the probability that the die lands on an even number? So I'll draw out my outcomes from rolling a dice. You got 1, 2, 3, 4, 5, and 6. All right, well, which one of those faces or outcomes are even numbers? Well, we have the 2, the 4, and the 6. So there's 3 favorable outcomes. So probability that we get an even number. There's 3 favorable outcomes out of 6 total outcomes, which we can reduce that to 1/2 or 50%. So there's a 50% chance, or a 1/2 chance, that we're going to land on an even number. All right, keeping on with the rolling the die example, what's the probability that it lands on a number less than 4? So what numbers are less than 4 on the die? There's a 1, there's a 2, and there's a 3. All other numbers are equal to or greater than 4, and we don't want those. We want the 1, the 2, and the 3. So there's 3 favorable outcomes. So we'll say probability that the dice, or the die, we'll call it D, is less than 4. Again, you can get a 1, 2, or 3. Those are less than 4. So there's 3 favorable outcomes out of 6 total outcomes, because you could roll a 1, 2, 3, 4, 5, or 6. So 3 out of 6, or 1/2. Or again, that's just 50%. What is the probability that it lands on a number less than or equal to 4? So this time, I'm going to write it like this, that the die, D, is less than or equal to 4. What's the probability that it's less than or equal to 4? So we'll take the outcomes from before, right? 1, 2, 3, those still work. Those will be less than 4. But we want less than or equal to 4. So we're going to include that 4 this time. So there are 4 favorable outcomes, rolling a 1, a 2, a 3, or a 4, out of 6 total possible outcomes, right? The 1, 2, 3, 4, 5, or 6. Let's reduce this to 2/3. There's our answer. Probability of rolling a number less than or equal to 4 is 2/3. Or if you want that as a percentage, just do 2 divided by 3 and then multiply by 100, and that'll give you 66.666 repeating percent. Another scenario where you'll see probability is playing cards. and gambling scenarios. And I don't recommend you gamble. There's way better things to do with your money and your time. But there is a probability aspect associated with games, with card games like poker and whatnot. So if you're playing for fun and you understand probability, you'll probably have a good chance of winning. But again, don't gamble. It's a waste of money. So in this example, in a 52 card deck of playing cards, there's usually 52 cards in a standard deck of cards. So we'll roll with that. What is the probability that I randomly pick a card and it's the ace of spades? So probability that I pick the ace of spades. So there are 4 suits in cards. There's spades, clubs, diamonds, and hearts. And there's only 1 ace for each of those suits. So that means there's only 1 ace of spades in the entire deck. So of our favorable outcomes, right, there are 52. Let's put 52 at the bottom because there's 52 cards we could pick from. But there's only 1 ace of spades. So the chance of pulling that 1 card is going to be 1 out of 52. And if we want that as a percentage, we could write that as 1.92%. So very unlikely that you reach in and grab that exact card that you're thinking, but there's still about a 2% chance of that happening. All right, now what is the probability of picking a heart? So again, like I mentioned, we have 4 suits in a deck of cards. You have spades, they look like that, kind of. You have clubs, like that. It's like a clover, and then you have hearts and diamonds. So what's the probability that you reach in and pick a heart? Well, there's an even number of cards for each suit. Just right below, there are 13 spades, there's 13 clubs, there's 13 hearts, and there's 13 diamonds. So if we want the probability of choosing a heart, well, how many hearts are there? There's 13. Out of how many cards in the deck? 52. And if we reduce that fraction, that comes out to be 1/4. And that makes perfect sense, right? Because there are 4 suits in the deck of cards. But we only want to pick one kind of suit, which is the hearts. And then if you want this as a percent, this comes out to be 25%. All right, next up, what's the chance that I randomly draw a card from our 52 card deck and pick a face card? If you don't know what a face card is, it's a card that has a face on it. Who would have thought? And those are going to be your kings, queens, and jacks. Each suit, the hearts, diamonds, clubs, spades that we saw just before, each suit has a king, queen, and jack. So there are 3 face cards for each suit. Well, how many suits are there? There's 4. So I have 3 face cards for spades. I got another 3 for diamonds. I got another 3 for clubs, and I got another 3 for hearts. That gives me 12 total face cards. Put that down here. Out of 52 total cards, so probability of drawing a face card is equal to 12 out of 52. If we reduce that, that's going to be, 6 out of 26, and then we can do that again, 3 out of, what's that, 13? Makes sense. And if we want that as a percentage, 3 out of 13, that's going to be 23.07%. If you don't know how I'm getting these percentages, you need to go figure that out on your own. All right, what is the probability I pick any card except the jack of diamonds? So we want to reach into this deck. I don't care what I grab, as long as it's not the jack of diamonds. We're going to call that a losing scenario. Well, how many jack of diamonds are there? There's only 1. So I can pick any other card. So probability not jack of diamonds is going to be Well, we don't want that one card. That's the one card we don't want. We want all the other 51 cards, but not that one. So I'll take any of these 51 cards out of 52. There's only one that I do not want. And the likelihood, that's probably not going to be able to get reduced. But as a percentage, that's going to be 51 out of 52, which is 98.07%. So that's a pretty high chance that when you go in and grab a card, you're not going to get the Jack of Diamonds. All right, let's talk weather. So on any given day in Florida, there's a 70% chance, I should write 70% chance that it will be a sunny day. How many days per year are going to be nice and sunny if that's the case? Well, we could think of it this way. Let's say another way you could phrase it is that in Florida, 70% of the year is going to be sunny. So we could write 70% of the year is going to be sunny. So, and I've mentioned before in my other videos that this word of in math means to multiply. Whenever you see of in math, chances are you're going to be multiplying the two things to each side of that word of. So I'm going to take 70% and multiply it by, let's go 1 year. So now that we got that, we need to change a couple of things. Well, we want how many days per year are going to be sunny. So let's change this year to days. So how many days are there in a year? There's 365 days. And when we multiply percentages, we need to convert them to decimal form first. So I'm going to write that as 0.70. And then do that times 365. So 0.70 times 365 is going to be 255.5. And we'll just round up to say 256 days. It'll be nice and sunny. All right, how many days per year are not sunny? So you could assume then if 70% of the year is sunny, well, that means 30% of the days are not sunny. And you could do the same thing here. You could go, I'll do it in kind of one step. 30% as a decimal, that's going to be 0.30. And I'm going to multiply that by 365 days. And I will get, say, 0.30 times 365. It's going to be 109.5 days. So we'll put that as 110. 110 or 109 is fine. I'll do 109 days here. That's one way you could have done it. You could have also taken your sunny days and subtracted that from 365 because there's 365 days in a year. If 256 of them are sunny, well, then the rest of them are going to be not sunny, and you'll get 109 if you do it that way. So 2 ways to do that question. All right, last one here. A lousy basketball player makes 25 out of 60 free throws in practice. If he attempts 24 free throws in an actual game, how many should we expect him to miss? So let's just start by figuring out what is the likelihood or what's the probability that he's going to make a free throw based on what he did in practice. So probability of making a free throw is going to be, well, he made 25 out of 60 attempts. If we simplify that fraction, we'll get 5 out of 12, and that comes out to be 41.66%. So that's all good and well. So he has a 41.66% chance of making free throws based on practice, which is all the information we have. All right, now he attempts 24 free throws in the actual game. So now with this percentage, let's figure out how many he made, right? I know the question's asking how many should we expect him to miss, but let's figure out first how many we should expect him to make. So if he's, the probability of making a free throw is 41.66%, right? We can expect him to make 41.66% of his free throws. So what are we going to do now, right? See the word of, that should instantly tell you, hey, we're going to multiply, and we're going to multiply this percentage and the number of free throws that this player took. So again, convert your percentage to a decimal. So we'll have 0.4166 times how many free throws did he attempt in the game? 24. If we multiply those two numbers together, we will get 10. So he had 10 made free throws. Again, this question is asking how many should we expect him to miss. So if he made 10 and he attempted 24, 24 minus 10 is going to leave us with 14. He missed 14 free throws.